Hey everybody, sorry I can't be there with you today. My son is really sick, and so we're going to push our lab to later in the week. But I wanted to do a quick thing showing you guys how to do some more calculations with free body diagrams. So let's say we have a box and it has a mass of 25 kilograms. Sorry, I'll try to get in closer for you there. There we go. And let's say that box is just sitting on the table. So what forces are acting on it? We know that gravity is acting in the downward direction, and we know that normal force of the table or whatever it's sitting on is pushing up. And so far, we've just kind of left it there. But today, we're going to learn how we can kind of fill in more of these arrows. So let's calculate Fg. You guys actually already know how to do this. Fg is just the weight. So Fg is equal to weight. And remember, weight is mass times gravity. Okay, so if I want to figure out Fg, or the weight, right, I'm just going to do mass times gravity. And so that would be, my mass is 25 times gravity. We'll assume this is Earth, which is 9.8. And so if you were to punch that into your calculator, you would get 245, and all forces should be in newtons. Okay, so now, next to this or below this Fg, I could write in 245 newtons. Okay, now here's a question. 245. There we go. How do I figure out Fn? Well, remember that if we have an unbalanced force, we see movement or change in movement. And if we have a balanced force, we see no movement or no change in movement. And so if this box is just sitting there, is it moving up and down at all? No, which means that my normal force must be balance out my force of gravity to make this a net force of 0, to make it unbalanced, which means my normal force is 245 newtons. Gosh, I did it again. 245 newtons. And as it turns out, normal force is always going to be equal and opposite to gravity. So that's pretty easy. You figure out one, then you can fill the other one in. Okay? So that's how to calculate gravity and normal force. Let's now try this, filling some more info in. Let's say now, actually we'll go back, let's say I push this thing to the right with a force of 50 newtons. So I could put an FA is 50, okay? And let's say I know that there's a net force of 35 newtons. Okay, well, if these two are balanced, that's going to be 0, which means the net force is from side to side. What force always opposes motion? That's going to be friction. So I can work backwards here to figure out my friction arrow. If the net force is 35, I've got, and it would be 35 newtons to the right, then I know that friction, if I do 50 minus 35, that must be 15 newtons to the left is what my force of friction must be, because then once I subtract those, that equals out a net force of 35 to the right. Does that make sense? So I can kind of work backwards here to fill in some of my other arrows. Let's do another one. Let's say we've got another box. It's got a mass of 15 kilograms. Okay. Let's say it is being pushed with a force of 10 newtons to the left. So being applied. Let's say we just know that there's 2 newtons of friction to the right. We can fill in Fg and Fn now, right? Because Fg, sorry, it's a little bit blurry here. Fg is equal to mass times gravity, so it'd be 15 times 9.8. And so that would give us 147. And again, that's going to be newtons. So I could fill in 147 for my Fg. And then normal force is always going to be equal and opposite. Okay, so now I've got kind of all my forces filled in, and now I can do some additional math. This is like the last question from our review. We can calculate the acceleration of this object. So if I look at this, what is my net force? Up and down at 0, but side to side, ooh, I've got a net force of 8 newtons to the left, right? So if I want to figure out the acceleration, I can use F equals ma. For my F, I'm going to use this net force of 8. For my mass, I'm going to use 15. And then I just solve for a. So I divide both sides by 15, and I get about 0.53 equals a. So that's meters per second squared. All right. Let's do one more. Let's say I have a ball. The ball has a mass of 0.5 kilograms, and it's falling to the ground. So let's calculate our forces here. We're going to have Fg, and to figure that out is going to be, again, mass times gravity, so 0.5 times 9.8. And so that would be 4.9 newtons. So my Fg is 4.9. Okay. Is there any force going in the opposite direction? Yes. That's air resistance, which is just a form of friction. Okay. So that's going to be going in the opposite direction. Now, air resistance is not going to always be like normal force where it's equal and opposite to. To fill in this, we would need more information. If this thing is falling at a constant speed, that means that my forces are balanced, and so my FF would be 4.9 if it was falling at a constant speed. If this thing was speeding up, that means I have an overall net force in the down direction, which means that my force of friction must be something less than 4.9. Okay, that would give me an overall net force down, so it would be accelerating downwards. Does that make sense? If something is slowing down, that means the overall net force is up. And so this force of friction would be bigger than my force of gravity. So it'd be something bigger than 4.9. If I had a friction of 5 or 5.5, then this thing would be falling but slowing down. Okay, so sometimes we can't always, if you're not told friction, sometimes you need some more information, like what is the object's motion? And based off of the motion, then you can figure out, oh, if it's constant speed, it's the same. If it's speeding up, FF is less. If it's slowing down, FF is more. And so that's a way we can fill it in. And then once you've got that info, you could figure out acceleration or things like that. So those are just some more examples of how we can just get a little bit more complicated, take this one more step further. And so today, for the rest of class, you all are going to be practicing drawing some of these and calculating some of these forces for different scenarios.